So let's look at this example problem. What's the frequency of a photon with a wavelength of 544 nanometers? And what type of electromagnetic radiation is this? So the first thing we want to do is we want to collect and organize our data. We want to be really clear about what information we're given and what we're trying to get to. So we're given that our wavelength is 544 nanometers and we're solving for frequency. Well, we know the relationship between frequency and wavelength. We know that if we want to solve for frequency, that's equal to the speed of light divided by lambda for all electromagnetic radiation. Now, I notice here that my speed of light has length in meters, whereas my wavelength is given length in nanometers. And that's going to be a problem. As I do my division, my length will not cancel out if these two lengths are in different units. So I want to go ahead and convert my nanometers to meters. And I want to remember that 1 nanometer is equal to 1 times 10 to the minus 9th meter. So as we solve here, I'm going to take 544 nanometers, multiply it by 1 times 10 to the minus 9th meter, divided by 1 nanometer. Our nanometers cancel out, and we're left with units of meters. So wavelength of 544 nanometers is 5.44 times 10 to the minus 7th meters. Now I'm ready to plug into my equation. C, the speed of light, 3 times 10 to the 8th meters per second, divided by 5.44 times 10 to the minus 7th meters. My meter units cancel out. And it's easier to see that in this fraction format of the division problem. And my seconds don't cancel out, and my units end up being 1 per second. The second remains in the denominator. And that is a frequency unit per second. So for electromagnetic radiation with a wavelength of 5.44 times 10 to the minus 7, there are 5.51 times 10 to the 14th waves that pass by a given point per second. Now, the question also asked for us to determine what type of electromagnetic radiation it was. So if I look back at my electromagnetic spectrum, I can see down here the visible region is given in units of nanometers. And I can see here that my given value is probably green light. It's definitely visible light. So the type of electromagnetic radiation would be visible light and probably green, since between 500 and 550 we see a transition from blue to kind of light green. So the key to doing these problems and converting between lambda and frequency is making sure that your length units cancel out. If you're given a wavelength that is not in meters, you're going to have to convert it to meters before you can plug it into this equation. And remember that any units for frequency should end up being per second, which is also equal to a hertz.